Every electronic device you use, yes, every single one, depends on a tiny component called a resistor. Without it, your phone could fry itself, your computer wouldn't even boot up, and that little blinking light on your remote? Gone. Hey everyone, welcome back. In this video, we're diving deep to really understand what a resistor is and why it's so important. So without wasting any time, let's get started. What is a resistor? Think of a resistor as one of the most fundamental building blocks in electronics. It's a component that limits or controls the flow of electrical current in a circuit. Now picture this. Electricity is like water flowing through pipes. And placing a resistor in that circuit, it's like putting a sponge in the pipe, not blocking it completely, but slowing it down. That's what a resistor does. It resists the current. And in doing so, it turns some of that energy into heat. Ever touched a working resistor? It might feel warm. That's totally normal. A resistor is a passive two-terminal component. Simple, but powerful. Why do we need resistors? So you might ask, why would we ever want to slow down electricity? Great question. Because electronic components are delicate. Too much current and poof, they're fried. Take an LED, for example. It only needs about 20 milliamps of current. More than that? It could burn out instantly. That's where the resistor steps in. Like a bodyguard saying, "Whoa, not so fast." Resistors are also used to create voltage dividers, adjust signal levels, bias transistors, pull logic gates high or low, and filter signals when paired with capacitors or inductors. So yeah, pretty versatile. Understanding resistance with Ohm's law. Here's where things get technical. But don't worry, I'll make it easy. Resistors follow one golden rule, Ohm's law. It states, voltage equals current times resistance, or simply V equals I times R. Let's break that down with an example. Say you have a 9-volt battery, and you want to power an LED using 20 milliamps. That's 0.02 amps. Rearranging the formula, R equals V divided by I, 9 divided by 0.02 equals 450 ohms. So to keep your LED safe, you'd place a 450 ohm resistor in series. Easy math, life-saving difference. The unit of resistance, the ohm, omega. The unit for resistance is called the ohm, symbolized by the Greek letter omega, named after Georg Simon Ohm, a German physicist from the 1800s. Resistors can range from less than 1 ohm to several million ohms, also known as mega ohms. And the idea is simple. More resistance equals less current, like turning down a faucet. Types of resistors. Not all resistors are the same. Here are some common types. Number 1, fixed resistors. Most common. Set resistance, no change. 2, variable resistors, potentiometers. Adjustable. Think, volume knobs, dimmer switches. 3, thermistors, change resistance with temperature, found in thermostats, battery chargers. 4, LDRs, light-dependent resistors, change resistance based on light, perfect for night lights or solar sensors. Each has its own role depending on the job. We'll explore these types in more detail in upcoming tutorials with real examples. Sizes of resistors. Resistors come in all sizes, and the size usually depends on how much power they can handle. 1. Through-hole resistors. These are the traditional cylindrical ones with wire leads. Common sizes, 1 to 4 watt, 1 to 2 watt, 1 watt, 2 watts, even 5 watts. 2. Surface mount resistors, SMD/SMT. Tiny rectangles on modern circuit boards like in smartphones. Some are so small they can sit on the tip of a pencil. 3. Wire wound power resistors. These are the big guys, used when high power needs to be safely dissipated. We're talking 5 watts to hundreds of watts. How to read a resistor value, the color code. Resistors don't usually have numbers printed on them. Instead, they use color bands. Each color represents a digit. Black equals 0, brown equals 1, red equals 2, orange equals 3. All the way to white equals 9. There can be 4, 5, or 6 bands. The first 2 or 3 bands are the base value, the next is the multiplier, and the last one shows tolerance. Here's an example. Brown, black, orange, gold equals 10 times 1,000 to 10,000 ohms or 10K ohms with plus or minus 5% tolerance. We'll break this down in detail in a future video. Real-world examples of resistors. Where are resistors used in real life? Smartphones. They manage voltage to tiny chips, cars, in sensors, lighting, and control units, TVs and radios for sound and signal processing, home appliances for motor control and power regulation. Even the charger you plug into your phone has resistors working quietly to protect your battery. What happens without a resistor? Remove a resistor and you allow unlimited current flow. That means overheating damaged components, potential fire risk in extreme cases. Fixed resistors are designed to provide a set, unchanging resistance value. This predictable performance makes them ideal for numerous applications in electronic circuits. They are essential in tasks like setting bias points, dividing voltage, and even in controlling current through delicate components like LEDs. In a fixed resistor, this resistance value does not change. For example, if you have a resistor with a value of 1 kiloohm, 1,000 ohms, and you pass a current of 10 milliamperes through it, you can easily calculate the voltage drop across the resistor. V equals 0.01 amps times 1,000 ohms equals 10 volts. This predictability is key in designing circuits because it allows engineers and hobbyists to set specific voltage and current levels in different parts of the circuit. Resistors might seem small, but they're absolutely essential for safe, stable circuits. Fun facts about resistors. Ready for some cool trivia? The largest resistors, used in high-voltage labs, can weigh hundreds of kilograms. In spacecraft, resistors are built to resist radiation. And surface mount device resistors? They're so small you could fit hundreds on a single fingernail. Resistors may not be flashy, but they are the unsung heroes of the electronics world. Without them, circuits would be unpredictable, dangerous, or just plain broken. If this video helped you understand resistors, go ahead and hit that like button and subscribe for more electronics, explained simply. Got a question? Want to see how resistors are made? Drop a comment. I read everyone. See you in the next one.